So let's look at the problem.
You're recording.
Is it recording? On this page, what do we want to do? We want to state the domain and range, right? Okay. There are several different kinds of functions here. Can you see clearly? Is this better? It's better, huh? Okay. Now, if we would like to look at the problem 1, okay? This is a radical function. So let me write here. So today is September 14. Okay? So let's look at page 6 on the packet. Can you see? We want to find the domain and the range for each function. Find the domain and range for each. So I'm going to choose several problems. This is a radical function. What is a restriction for radical functions? We have to make sure what? The radicand has to be or 0, right? So the radicand, this is my radicand. Okay? So let's review. What do we know? If you have square root of x, x has to be what? Greater than or equal to 0. Am I correct? Yes, great. So now, what is inside? Negative 188 minus x. So you would say, all right, so the domain should be all the values of x such that negative 188 minus x need to be greater than or equal to 0. Is that okay? This is the radicand. Sorry? All right? Then you try to tell people, all right, then what is my x? So try to add x on both sides. So you say negative 88 greater than or equal to x. Right? And what is that? That means x less than or equal to negative 188. And x is a real number, right? That is a domain. The domain will be the value making the radicand greater than or equal to 0. For example, like this. This is our basic function, square root of x, right? What is the domain for this radical x function? It will be all the value of x such that x greater than or equal to 0, right? And x is a real number. Is it okay? All right. So now let's look at this. X needs to be less than or equal to negative 188. So let's choose a point. Let's say that is negative 188. So all the points less than that, it will be all the points to its what? To its left. You see that? What do you mean x? Oh, sorry. Okay. What do you mean by x less than or equal to negative 188? It means all the points to its left. Okay. And the interval notation will be negative infinity to negative 188. Is that okay? Yeah. All right. Okay. Let's look at the original function here. So, do you remember for radical x, what is the restriction for x? Can x be negative? No. It will not be real, right? It's an imaginary number. Could x be 0? Yes. Because what is square root of 0? It's just 0. So 0 is okay, right? If you have square root of negative 3, then it is not a real number. Not a real number. If square root of positive number, square root of 4, it will be what? 2, right? Square root of 5 is a real number, right? Okay? It is okay. It is okay. It is okay. But not negative, right? So when you have a radical function, then you know the radicand has to be positive or 0. Is that okay? So look at this problem. You have what under the square root? What is under the square root? Negative 188 minus x. So you tell people, okay, the whole thing has to be greater than or equal to 0. Is that okay? So you say that has to be like this. So you say, hey, this needs to be greater than or equal to 0. Is that okay?
Why does it have to be greater than or equal to 0? Isn't it negative? Isn't a negative less than 0?
Okay, let's not to think about that. We think about that later. But right now, we just want to know this is the right description. Okay? We say all the x such that this greater than or equal to 0, right? And then we worry about how do I find those x. But at least you tell people, I am looking for all the values of x which will make the radicand greater than or equal to 0. That is the right description. Okay? And then we try to solve this. Say, okay, what is x? So what is x? This is inequality. Remember, we can add both sides by the same thing. So can I add negative, can I add x on both sides? Yeah. So then I will be able to find x should be less than or equal to negative 188.
So, but it says right there, okay.
Negative 188 is greater than x, right? Or x is less than or equal to negative 188.
So we're always going to put it at the domain greater than or equal to 0? Is that always going to be like what we have to put?
For the radical functions, you're always finding the value, making the radicand greater than or equal to 0. Yeah. Is that okay?
Why is not a real number for negative 3 over here?
Where?
Negative 3 is not a real number. How come this is a real number? Negative 188.
Yeah, I was wondering about that too, because it has a negative.
That is for this function. I'm making this greater than or equal to 0. I'm not making x greater than or equal to 0. I'm making the whole radicand greater than or equal to 0. Is that okay?
So we can't make the negative 3?
No, this is, okay, look. Let's choose a number. Let's choose a number inside here. For example, like negative 200. Okay? Negative 200. So putting negative 200 here. Negative 200. So negative 188 minus negative 200. That is positive 12. So square root of positive 12 is okay. Yeah.
But outside,
Outside is fine.
there's a negative outside.
That's okay. That's negating that result. A real number, when you try to find its opposite, it's still a real number.
So negative 3 is not real number.
No. It's the square root of negative 3 is not a real number. Square root of a negative number is not a real number. Okay? But when you put negative 200, the whole thing here is 12 positive, right? So square root of 12 is okay. Right? Good question. Do you understand? Yeah, if it's one, if the answer, if x is negative 188, then it will be negative 188 plus 188, which is 0, right? Square root of 0 is what? 0, right? Negative 0, still 0. Is that okay? How about choose a number that is less than negative 188? How about negative 189? Okay, negative 189. Okay, x equals to negative 189. All right? Choose this point, negative 189. All right? This point is less than negative 188, right? Yes. Negative 189, if you put here, it will be negative 188 plus 189, and that is what? 1. What is the square root of 1? 1. And then you have a negative, it will be just negative 1. Is that okay? All right?
I think everyone's got confused because the symbol how it's less than.
Yeah.
You mean here?
Yeah.
Well, it makes sense because what you're trying to say is we're going backwards.
Right.
X squared is negative.
Uh-huh.
Negative is positive.
Right.
1 and 1, 8.
Right.
So subtract it from positive.
Okay, then let's look at the other problem. Maybe it will help you more. Okay. What is the range for this? Okay, what is the range for this? What is the range for this? First of all, you want to know, let's recall, what is the graph for this radical function? The graph for this radical function, if it's 1, when x equal to 1, square root of 1 is what? 1, right? When x equal to 4, square root of 4 is what? 2, right? You get this. This is the graph of square root of x. Okay? You can make a little table. Say, when x equal to 0, y equal to 0, right? So here is 0, 0. When x equal to 1, square root of 1 is what? 1. So you have 1, 1. Is that okay? Is that okay? When x equal to 4, what is square root of 4? 2. So this is 4, comma 2. Is that okay? What is the next number you would like to try? 9. Square root of 9 is what? 3. So 5, 6, 7, 8, 9. So when x equal to 9, it will be 3. Is that okay? This is a graphing for square root of x, right? Now, what is this graph? This graph is negative of this function. So if you have square root of something, it's always greater than or equal to 0. Now, it becomes what? Multiply by negative sign. So it will be what? Less than or equal to 0. So the domain is this, and the range will be negative number. The range will be all negative number. Is that okay? When x equal to negative 188, it is 0. Right? Is that right? Okay. And others will be all negative. Yeah. Yes? Okay. Now, let's look at the other problem. Problem 4. Okay? Can we look at that problem? y equals to x over x plus 20. Now for this problem, what is the domain? All right, so the domain will be, what is the domain? It will be all the value of x. Now you have numerator, you have denominator. Uh-oh, when you see denominator, you know denominator cannot be 0. Are you all with me? Are you all with me? Gentlemen? Are you all with me? What is the restriction for x? The denominator cannot be 0, right? So the domain will be all the values of x such that denominator cannot be 0. I write it down, but then of course, usually, we know what is the denominator right now. Can you tell me what is the denominator? X plus 20. You are awesome. And x is a real number, right? X can be any real number. Denominator cannot be 0. All right, my friend, when you say x plus 20 cannot equal to 0, means x cannot be what? Negative 20. Is that right?
Yes.
And x is a real number, right? Okay, so let's graph it. When you say x not equal to 20, it could be any number except negative 20, right? So when you get up to negative 20, it's an open circle, right? But when you draw it, we like to have all of you draw in the way that using parentheses or bracket to represent whether that point is included or not included. So you use open parentheses, so you know it will be what? Either left to negative 20 or right to negative 20. So in interval notation, it will be negative infinity to negative 20, and then union negative 20 to infinity. Are you with me? Okay? Well, I said already you use open circle to represent that point is not included, right? Yeah. Okay, but if you use parentheses, you already told people that that point is not included. Okay? So our practice in this course, we are using parentheses. Is that okay? Okay, now choose another problem. How about problem? Oh, what is the range, huh? What is the range for this problem? Okay, let's see. What is the range for this problem? This is a rational function. What is the range? Let's see this this x could be any number. This x plus 20 could be very large, could be very small, because we said already x could be all kinds of real number. Is that right? Yeah? Are you all with me? Yeah? Okay. So what happened to x? What is the value that that y should be? This is a little bit harder for you. Let's try to look at this.
How do you know x
Cannot.
How do you know it can't equal the
Cannot equal to negative 20. Because if it equals to negative 20, negative 20 plus 20 will be 0. Then the denominator will be 0.
Okay. Can you explain the graph again for
For
these?
this part?
Yeah.
Okay, because negative 20 has to be excluded, right? Yeah. So how do I express all the numbers except this point? You would say either this open interval, negative infinity to negative 20, or The point should be on that open interval. Okay, so you have the union to represent either here or there. How about the range? Let's see. The range, let's look at y, right? So we care about y. What is y? Y is x over x plus 20. Okay? What is that? That is x. This is a little bit challenging for all of you. Okay? So it is x plus 20 over x plus 20 minus 20 over x plus 20. So it is equal to 1 minus 20 over x plus 20. Okay? You might ask me, Dr. Chen, how do you know? It's a bit harder for many of you. I'm trying to figure out the value of y by rewriting it. Actually, I'm doing the division, right? Do you remember how to do this long division? Let me do it for you, okay? X divided by x plus 20. Do you see that? Yes or no? Yes. So look at x divided by x. What do you get? 1. So 1 times x, you get x plus 1 times 20, 20. Do you see that? And then what do? You subtract, right? So x subtract x, gone. And here is what? 0. 0 subtract 20 is negative 20. Is that right? Yes? So the quotient is what? 1. The remainder is what? Negative 20. So the answer will be 1 plus, so let me write it, plus negative 20 over the divisor. This is how you do the long division. Do you remember? Yes, good. I'm so happy. All right? So x over x plus 20 is 1 plus this quantity. Is that okay?
Is that the range?
This is y. Okay, and then we are going to talk about, so what is the range? What is y value? So you see, if I don't have this, can you tell me what is the range? Look at this. It could be any value except what? 0. How do I get? Oh, because I'm adding 20 and then subtract 20. So there is still x.
0 minus 20.
Yeah. You can just mind this, okay? Can I have all of you focus on this? Remember this long division, right? All of you should have learned this long division. X divided by x, what do you get? 1, right? 1 times x, you get x. 1 times 20, you get 20. And then you subtract. And this is your what? Remainder. So the quotient is 1. And then plus the remainder over the divisor. Is that okay?
Yes.
All right. Who forgot about the long division? Okay. Now does it help you to recall a bit? Okay. All right. For now, I will tell you what kind of domain and range I will test you next week. Okay. I will mainly test you domain. The range will be much later. But some of the things, if I'm going to test you range, I will, specifically tell you. For this problem, I will not test you this problem for the range. But I want you to learn it now. Okay? Long division, you have to review. Long division. Okay? This is a very basic skill. Now, here, look at this. This value could be any real number except 0. It will never ever become 0. Am I correct? Okay? All the numbers except 0. Is that okay? All right. So by plus 1, it means it will be any real number except 1. Because you cannot lift up everybody by 1. Therefore, okay, I'm going to write it down. This part could be all real numbers except 0, right? Okay? So by adding 1, then you will say, well, if the y value is going to be all real number except what? Except 1. Because you are adding 1 now. Okay? Okay? All real number except 1. Right? For this, it's all real number except 0. So plus 1, it will be all real number except 1. So the range will be all real number except 1. Okay? Great job. Good question. All right, let's look at next problem. Can I have you look at problem number 17? It will be so straightforward. How about y equals to square root of x plus 31? Okay? Oh, set builder notation. It will be saying y value, y cannot be 1, but y is a real number. Okay? Okay, how about for this one? Well, then now you know what is a domain. The domain will be all the x such that x has to be what? Greater than or equal to 0, right? And x is a real number. Okay? So far, so good? Okay. Now, what about the range? What about the range? Oh, then let's see. Then you say, well, Dr. Chen, I only know what is the range for square root of x. What is the range for square root of x? Let's recall. Do you see the graph here? What is the range for square? This is square root of x, right? Is this square root of x? Yes or no? Yes, this is square root of x. The domain is what? From 0 to infinity. And the range is what? From 0 to infinity. Do you see that? Square root of x is greater than or equal to 0. See? It's above the x-axis, right? Yesterday we practiced, right? So what do you mean finding the range? You find all the possible y value, right? What are all the possible y value? Look at the graph. See, where is the graph? All the graph now is above x-axis. Okay? Who doesn't understand this? Raise your hand. The range for this. What is the range for radical x? Very good. So it will be from 0 to infinity. Is that right? The range for the radical function, see, all the y's are positive or 0, right? Is that okay? So because of that, now if we look at the, okay, now I'm going to use that to look at this function, okay? Radical x plus 31. Now you know radical x, its range is from 0 to infinity, okay? How about this? Radical x plus 31. It will be greater than or equal to 31. Great, great, good job. Good job. So what does it do? What does it do? Okay? What does it do? So let me draw it. Okay, and this is going to connect with what we are going to learn today. When it is 1, I get 1. When it is 4, I get what? 2. When it is 9, I get what? 3. Thank you. right? Okay. Now, this is my graph, y equals to radical x. So if you draw a table for x, you say 0. When x equal to 0, my y value is 0. When x equal to 1, radical 1 is 1. When x equal to 2, when x equal to 4, radical 4 equals to 2. I try to choose the number that square root of that number equal to an integer. Of course, you can use other value, but right now, for us to graph it easily, we try to choose a complete square number. Square root of 9 equals what? 3. Okay. Now, but right now, my function for this question is square root plus 31. So let me create another table. This is y equal to square root of x plus 31. So what happened to the value of y right now? When x equal to 0, it's still 0. But you have to plus 31. So it is what? 31. When x equal to 1, you get 1, but you need to plus 31. So you get 32. When x equal to 4, it is 2, and then plus 31. So you get what? 33. When x equal to 9, you get 3 plus 31. So you get what? 34. So what happened? It's like every point on this graph, it's going to be shift up how many units? 31. So shift up 31. Shift up 31. Shift up 31. Do you see that? And 0 shift up 31, you will go up to 31, right? And this is 32, and that is 34, 33, and 34. So you will get something like this. Does it make sense to you? So the whole thing here is a what? Is a shifting what? Up, right? So you know what? In the future, when you see this, you say, Dr. Chen, I'm not going to draw this anymore. I only need to know this. This is my fundamental function. Okay? By knowing that this is my fundamental function. This is my fundamental function. Okay? I only need to know the shape of this fundamental function. Then, to do this, I just need to shift up how many units? 31 units. Because, look, I'm getting y equal to radical x. Okay? Look, this is y equal to radical x. The whole thing will be the same, except my y value is adding 31, right? Every output, every point is shift up 31. Is that okay? In what direction? In the y direction. It's a vertical direction. So this is a vertical shift. Okay, one more time. How do I graph this? You say, I recognize this is my fundamental function, and I know its graph. Do you know this graph now? Yes. So I know this graph, and to get this, is my every y value is going to be added by 31. Do you see every y value being added 31? So every point is going to be shift up in the y direction, in the vertical direction, up 31 units. Is that okay?
What are you doing with the 1, 4, and 9?
They are with the same x.
Are you following some sort of rule, or did you just make those numbers up?
Those numbers are complete square, so it's easy for me to get the output to be integers.
Oh, okay.
Okay? I definitely can use 5, but then square root of 5 is not an integer. It's an irrational number. It's hard for me to graph it. Yeah. Okay. Okay, thank you. All right. So what is the range? Then the range will start with what? 31 to infinity. Okay? So far, so good? Okay. Now look at the problem 18. Okay, let me put that as my part D. Y equals to negative 5x minus 4. Okay, for this one, what is the domain? The domain will be all the x value. What are all the x value? X value could be any real number, right? Okay, so we say the domain will be all the values of x such that x is a real number. There's no restriction. Okay, so the domain will be the whole set of real numbers. What about the range? What about the range? Also from negative infinity to infinity. What is the shape of this equation? It's a straight line. Is that right? Yes? What is the y-intercept? Negative 4. What is the slope? Negative 5. Is that okay? All right? You can graph it if you want to.
What about problem like 15?
Sorry?
What about problem like 15?
Problem like 15. Okay, let me get 1, 2, 3, 4, negative 4. And then it says negative 5 as a slope. So 1, 2, 3, 4, 5. Is that okay? This is y equals to negative 5x minus 4. Okay, number 15. Before we do number 15, let me ask you, what is the domain for this? Y equal to x squared. Do you know this function? Y equal to x squared? It's a parabola, right? Y equal to x squared. Okay? What is the domain for this function? It's whole real number, right? Okay? The domain will be all real number. Okay? Let's graph it. When x equal to 0, if you want, put a table. When x equal to 0, y equal to what? 0.
Where did you get e from?
I created. Yeah. This is a fundamental function. When x equal to 0, y equal to 0. When x equal to 1, y equals to 1. When x equal to 2, y equals to 4. When equal to 3, y equal to 9. How about negative value? When x equal to negative 1, y equal to what? Also 1. When x equal to negative 2 times negative 2 is 4. When x equal to negative 3 times negative 3 is 9. So you can plot it. 0, 0, 1, 1, 2, 4, 3, 9. Yeah? And for negative 1, you also get 1, right? Negative 2, get 4. It's symmetric about what? About the which axis? How do you see that? Yes, it's with respect to the y-axis. It is symmetric with respect to the y-axis. This is my y-axis, right? It's a symmetric with respect to this y-axis. This is a parabola facing up or facing down? Facing up, okay? And you can see the coefficient in front of this. You don't see it. It means what? It's coefficient 1 is positive, okay? If you recall what you learned before, if the coefficient is positive, it's always facing up, okay? So now the x value could be any real number. So the domain will be all real numbers. How about the range? My good friends. Are you with me? What is the range? What is the range? What is the range? From 0 and up, right? Because the graph is 0 and up. So the range is from 0 to infinity. Is that okay?
Yes.
So far, so good? Okay. So now, let me have next problem. I make it up, okay? I make up this problem. X minus 1 square. It's a little bit bright, huh? Is it okay now? It's better, huh? Okay. What about this? What about this? Domain? Is there any restriction about x? No, right? It's not in the denominator. It's not under the radical sign. So what is the domain? All real numbers. Is that okay? What about the range? What about the range? Look. This is something square. Something square. Something square is always what? Greater than or equal to 0. Yes. So the range is 0 to infinity. Is that okay? So now I can do number 15. Number 15. How do I get range again? Sorry? If I put 0 here, it will be negative 1, negative 1, negative 1 is positive 1, right? What about 1? 1 minus 1 is what? 0. 0 squared is 0. So the minimum value will be 0. And it happens at 1. Okay? Is that okay? Now, I'm giving you another problem that is, okay, so how about this one? So this is a bit different. X minus 3 to the power 16. It's even power, right? So I don't have any restriction for x. So what is the domain? All real number. Okay, now what is the range? The range will be, since the power is 16, that is even, right? So when you have even power, what happened to the outcome? It will be always positive or at least 0, right? Is that right? So it's from 0 to infinity. Is that okay? So far, so good? Why that? What is what? What if it's not even? If it's odd? If it's odd, then it could be positive or negative, right? Then it will be all real number. Yeah. So good question. So I'm going to do that later, okay? So now let me give you another problem. Go slowly. So y equals to, say, 8 times x minus 3 to the power 20. Okay, what happened to this? Well, you have to know it's a number 8 times this, right? So look at that. That is what? That is an even power function, right? So the domain will be all real number, and the range will be starting from 0 to infinity, right? Okay, that's your output without multiplying 8. If you multiply 8, the range still from 0 to infinity, because you just make 0 times 8 still 0. All the positive number times 8 is still positive. Am I correct? All right? So, all right, so I'm going to call people to answer my question. What is the domain for this function? Negative infinity to infinity. What about the range? You have bracket 0 to infinity. Right? Because this part, for this part, is always greater than or equal to 0, right? Because this is even. Even power, right? Is that okay?
Yes.
So if this greater than or equal to 0, times 8 still greater than or equal to 0. Negative 8. Yeah. Then that will be, everybody will shift down 8. Yeah. You are perfect, because this is connected to what we are going to teach in about 2 minutes. Okay. So now let's look at that problem. Number 15. Y equals to 131. 9x minus 3 to the power 62. Okay, so what happened to this? What power? 62. The power is even or odd? Even. So the whole expression without 131 should be greater than or equal to 0, right? Times 131, still what? Greater than or equal to 0. So what is the domain, my friend? Will be negative infinity to infinity, right? What is the range, my friend? It will be from 0 to infinity. Is that okay? All right. Some of you ask me, Dr. Chen, what about if I have odd power? So I'm going to show you for J, if I have y equals to x cubed, what happened to x cubed? X cubed. So now let's graph. What is x cubed? X cubed, when x equal to 0, y equal to 0. When x equal to 1, y equals to 1. When x equal to 2, y equals to 8. Oh, it's so large. So what do you get? It's increasing so fast, right? Is that increasing so fast? How about negative 1? When x equal to negative 1, negative 1 cubed is negative 1. How about negative 2? Negative 2 cubed is what? Negative 8. I say you should use your graph paper. I'm hoping that it helps you. Okay? This is x cubed. What happened to x cubed? Oh, if x is positive, it will be positive. If x is negative, it will be negative, right? Yeah? So what is the domain, my friend? The domain is negative infinity to infinity. What about the range? Negative infinity to infinity, right? Is that okay? Yes or no? Yes. Okay. Now, I would like to put them all together. You have learned a lot today. You probably don't know, but go through all these practice. You already getting some idea like how you go from old function to a new function by multiplying something or by add or subtract something. Okay, so let me go over one more fundamental function, and then we will put all the things together. Okay, can you do the function for absolute value of x? How do you draw absolute value of x? Well, when x equal to 0, it is what? 0. When x equal to 1, it is 1. When x equal to 2, it is 2. When x equal to 3, it is 3. Super easy. It's actually like y equal to x when x greater than 0, right? What about negative values? When x equal to -1, it's still 1, right? Because you are taking absolute value. When x equal to -2, it is 2. When x equal to -3, it is 3. So sorry, thank you. So when x equal to negative value, it's just like the function y equal to negative x, right? Is that okay? Okay, let's look at the negative part. When x equal to -1, so what is y? Y is absolute value of -1, which is 1. When x equal to -2, what is absolute value of -2? It is 2, right? When x equal to -3, y is absolute value of x. So it's absolute value of -3. What is that? 3. Is that okay?
So it's just going to be like the opposite when it's less than 0. You just put the opposite sign.
Yes. Remember the definition of absolute value? It is x if x greater than or equal to 0. It's opposite of x if x is less than 0. Right? You are so wonderful. Yes. That is a very nice way to understand absolute value. The understanding of absolute value is when x is positive, it's itself. When x is negative, it will be its opposite. Okay? Which is y equal to negative x. Okay. So we have gone through many fundamental functions. And we would like to learn how do you go from those fundamental functions to something we call transform function. Okay? So now let's see. Transformation. Okay, how do we transform functions? When we fundamental functions. Let's put together all the fundamental functions, okay? The first one is linear function. The basic one will be y equals to x. What is y equal to x? It's like this. Yes? The second one, say absolute value. Absolute value function. Okay? We just did, right? 1, you get 1. 2, you get 2. 3, you get 3, right? quadratic function. One, you get 1. 2, you get 4. 3, you get 9. -1, you get 1. -2, you get 4. And -3, you get also 9. It's symmetric about the y-axis. Y equal to x squared. Okay? Number 4, you have cubic function. Y equal to x cubed. Okay? 1, you get 1. 2, you get 8. It's increasing very rapidly. Okay? Are you following? We have already drawn all of this earlier. Number 5, rational function. Y equal to 1 over x. Okay? It's not defined as 0. Is that right? When x equal to 1, it is 1. When x equal to 2, it will be 1/2. When x equal to 3, it will be 1/3. When x equal to 4, it will be 1/4. Like this. When x equal to 1/2, it will be 2. When x equal to 1/3, it will be 3. So what do you see? You're seeing when x getting closer and closer to 0, the value is getting larger and larger. How about negative value? When x equal to -1, it is -1. When x equal to -2, it will be -1/2. When x equal to -3, it will be -1/3. It's getting smaller and smaller. Getting closer and closer to 0, right? When x equal to -1/2, it will be -2. Is it small for you? Is it okay? For this 1 over x. Okay. All right. So what do you see? Oh, it will not cross the y-axis, right? Because when it gets very, very close to 0, the value is like negative point something. Then 1 over that will be very negative. Yeah? So let's see, -1/10. -1/10 is very close to 0. What is 1 over -1/10? It will be what? -10. Oh, it's here, right? So when it is very close to 0, its magnitude is going to be very large, right? Either in the positive side or negative side. Okay. Next, radical function. Y equal to radical x. So what happened to this? Remember, 0 you get 0, 1 you get 1, 4 you get 2, right? And 9 you get 3. So this is the shape of the radical function. Is that okay, my friend? Okay. How do I graph this? Now, let me give you an example one. Okay? How do I graph y equals to x minus 1 squared? Where is x squared? It looks like x squared, but except it has x minus 1. Am I correct? Yes? So we say, actually, if we plot the points, x, y points, what would happen? What would happen? Let's look at this quadratic function, x squared. 0, you get 0, right? 1, you get 1. 2, you get what? 4, if it's x squared, right? If y equal to x squared, right? 3, you get what? 9. Good job. Now, look. This is my new function. Uh-oh. My x need to minus 1. So if I would like to get the same y value, okay, let me put it here. I want to get 0. I want to get 0. Well, if I don't have this minus 1, what is the x value for me to get 0? 0, right? But because I have minus 1 here, so my new x value needs to be 1 more. So what is 1 more than 0? 1. Right? Because you are going to subtract 1. You are going to subtract 1. So your new value needs to be 1 more. Okay, how about to get 1? In order to get 1, it was 1, but because I'm subtract 1, so it needs to be 1 more. What is 1 more of 1? 2. You see what I'm saying? So, all right. In order to get, okay, the whole thing, in order to get 1, this should be 1, right? Yes? So my new x value needs to be 1 plus 1, right? Because you are going to take away 1. One more.
1 or 1 minus 1? You change the sign completely?
Okay, look. Here. Then this is x minus 1 squared, right? This is my new value. In order to get 0, in order to get the same y value, my new x, this is my new x, right? Need to be 1 more compared with the old one. Because my x value is going to subtract 1. So in order to get the same y value, I need to be 1 more. So I subtract 1, then I can get to this and get the same y value. Okay, one more time. The goal is to get the same y value. To obtain the same y value.
Same y value as the y equals x squared?
Right, right. My new x value needs to be 1 more. Okay? Look, this is x squared. This is something square, right? This is something square. So the whole thing are in the same structure. This is something square, this is something square. Here's x squared. I know very well about its graph. It's like this. Okay, so I am expecting my new function will have similar graph. Okay, so let's obtain the same y value. In order for me to get the same y value, because my x is going to subtract 1, so my new x value need to be 1 more so that I can get the same y value. Okay, so let's look at 4. How can I get y equal to 4? How can I get this value equals to 4? So you would say you need to have this to be 2, okay, because you are going to subtract 1, so this needs to be 1 more. So it should be what? 3. Does it make sense? Okay, so because x value needs to be 1 more, x value, x is horizontal line, right? It's x-axis. X value need to be 1 more. It's in what direction? To the right or to the left? To the right. So we just shift the original graph to the right, right? When you say one more, means add one to the positive direction. So you shift to the right. Shift the graph to the right 1 unit. Okay? Is that okay so far? I'm going to graph it. So, y equal to x squared. This is my fundamental function. 0, 0, 1, 1, 2, 4, 3, 9. So I first graph the fundamental function y equals to x squared. Okay? So you say, step 1, you will graph y equal to x squared. Step 2, what do we graph? We just shift it to the right 1 unit to obtain y equals to x minus 1 squared. You shift to the right 1 unit. Everybody shift to the right 1 unit. Okay? So you are going to get the origin is going to be here. So this is y equal to x plus 1 squared. Is that okay? All right? Are you with me? X minus 1. Thank you. That's what I said, and I didn't write it that way. X minus 1 squared. Okay? Yeah.
So, for example, was x minus 4, you would shift the 4 to the right?
Yes. If x minus 4, you shift to the right 4 units. If x plus 4, you will shift to the left. Okay? Is that okay? This is the part so beautiful. Save us a lot of time graphing. Okay? So with that, I would like you to do the transformation. So now you don't graph by plotting points. Now you are going to plot by transformation, shifting. Okay? So with that is when you have this inside, you are shifting to the right or to the left. But if you are going to have plus 1 or minus 1 outside, it's shifting up or down. Okay? All right. Yeah, why? Because in order to compensate this minus 1, the new value need to be 1 more to get the same y value, right? Yeah. So to be 1 more means what? To the right. Yes. Okay. You are going to do your homework the same up to, I'm going to have you do the shifting. You can now do up to the page 19. If you use the shifting, you can do up to 19. Okay. And I'm going to place this video that we tape from now on, upload to Canvas. Okay. Would that be helpful to you guys? Okay. Give us some time because I think they need to do some closed caption. Okay. And at the same time, I'm going to give you some keys for this packet. Okay, not for every problem, but some problems, just to help you. Would that be helpful to you? Yeah? Okay, so remember up to page 19, and there's some My Math Lab section. I will leave that on Canvas as well. Okay, so try to check your Canvas. On the way out, please sign up. Okay, I need to take roll. I'm collecting the test. Just leave by the door. Okay? Would you please sign your name here for today's roll taking? Thank you. And the correction and the test. Put the correction on the back. Okay? On the back. Yeah. And leave it on the desk. Thank you very much.